Ever since the concept of turning a spent rocket stage into a station originated in the 60s, it has been largely overlooked, with space agencies instead designing heavy launch vehicles to deliver large parts to orbit. However, as we look towards establishing effective interplanetary travel and building stations around and on other planets, the space industry has been progressively designing more reusable, wasteless technology and looking for ways to maximize the payloads that can be heaved off the surface of planet Earth. There are many ways we can make a rocket reusable or wasteless, and most of them involve landing or collecting used boosters, or designing refueling depots for spacecraft that have run out of fuel. This way, we don't depend on building a new rocket for each launch or each journey we make through space. However, there will always be rocket parts that are wasted or become unusable for conventional launches, so there must be something we can do with all these leftover tanks and rocket stages. In this video, we'll discover how spent rocket stages can be reused and turned into space station modules or individual hubs that can travel through space between the Earth, Moon, and Mars. You're watching 26 Dimensions, the space exploration and astrophysics channel here on YouTube. Why not support me by subscribing? In the future, we want to establish a travel route between the Earth and Mars, preferably using the Moon as a stepping stone on the way there. Currently, NASA is working on their Artemis program, which aims to construct a revolutionary new space station in orbit around the Moon called Lunar Gateway. Depending on the success of NASA's SLS rocket and the first uncrewed Artemis mission, this station could emerge in the next 2 or 3 years. NASA has changed tactics with the Artemis program in the past decade, contracting many smaller space agencies to help build parts for their flights and new space station. Because they envision the Lunar Gateway being expanded with third-party extensions, so in the future, many organizations can visit the Moon, the Lunar Gateway needs adequate technology to quickly and cheaply build modules. Where can we get the materials for such extensions and easily apply in-space manufacturing to them? Of course, the answer is by converting spent rockets into space stations. After a spacecraft has completed its launch or powered journey through space, it will separate from its rocket stage, abandoning a super useful, ready-made metal cylinder that can have so many alternative purposes. Even though the fuel is gone, it is more sustainable to convert a rocket stage into a space station than to launch an entirely new rocket to deliver parts. Heavy lift vehicle stages could be refitted with internal fixtures to convert them into habitation spaces. Refurbishing an old rocket stage and making it into a living space necessitates several crucial EVAs to fix docking apparatus, ship important parts into the tank, and hook up electricity supplies. This process could be performed by a small group of astronauts across a few days, or even automatically using advanced robotic arms, like the one the International Space Station employs. In most conventional rockets, most of the structure, every stage, every installation, and every module is wasted. However, if we can find an efficient way to reuse these parts in space by turning them into habitation places, then we'd cut out the need to transport space station parts on extra launches. The defueled and wasted rocket would become the payload, instead of you having to make several flights to deliver space station pieces. Nanoracks, a space agency that spent many years manufacturing and delivering parts for the International Space Station, is now working on a project called Outpost to transform rocket stages into station units that can be lived in, experimented in, or used for storage of resources like food, water, and tools. Nanoracks believes that with more funding and support from agencies like NASA and ESA, they can refine the Outpost technology to begin to populate the solar system with hubs that can be adapted for a range of specialized purposes, such as fuel depots, food production and storage plants, and even temporary residences for astronauts on interplanetary and deep space missions. As part of NASA's Next Step program to stimulate the commercial space industry and advance deep space travel technology, a contract has been signed with Nanoracks. It will allow them to collaboratively develop their Independence 1 space station, used for converting the second stages of rockets into habitation modules. NASA is trying to push commercialization of space habitation and risk reduction of living in space, and contracting Nanoracks to build standardized space station modules will hopefully advance this field rapidly. Nanoracks is no rookie agency. They've launched the International Space Station's Cube satellites for years, and in 2020 they successfully released their own new airlock design, which is installed in the International Space Station. Currently, they operate laboratory space on the ISS and may even attempt to develop their habitation modules alongside this base, using the station to test their designs in orbit and perfect the docking system. The most exciting part of Nanoracks' ambition is they have a spaceflight planned for 2021 where they will test their robotic construction technology. But not around Earth, no. Nanorack is stitching a ride on a SpaceX rocket to Mars, where the designated payload will detach and begin its work in Martian orbit. Mars Demo 1's payload will contain a large metal cylinder similar to a typical orbital rocket's upper stage. A robotic arm attached to it will perform the work in cutting and welding the metal to form an airtight habitation module, fitted out with a protective framework and the basic necessities for a space station unit. Mars Demo 1's robotic arm is equipped with a friction milling end effector which should make clean, flawless cuts in the rocket stage's metal sheets. The aim was to absolutely minimize space debris, preferably leaving no waste at all. By melting the metal with a cutting apparatus that is spinning at a high RPM, any escaping debris is melted and fused to the body, preventing it from cluttering Mars orbit. We expect to see Mars Demo 1 take off on a Falcon 9 rocket in June this year. There's been a lot of hype around the massive payload capacities of heavy launch vehicles like NASA's Space Launch System and SpaceX's Starship recently. Starship, for example, is targeting a payload capacity of 100 tons, which would allow large space station parts to be lifted into orbit and even to Mars very easily. These rockets will help push the boundaries of what is possible with space construction and deep space exploration. But I'd say that Nanoracks is making just a significant contribution as NASA and SpaceX. If Nanoracks can prove that its robotic technology can quickly and efficiently convert spent rocket stages into space stations waste-free and put its first outpost in space, then there will be a huge surge in commercial space exploration. Cheap, customizable, and readily available space station modules that can be made at orbital plants around Earth and Mars will make it possible to establish a heavily frequented travel route between the two planets. Likewise, it will empower rockets to travel much farther as they'll be able to refuel at the Moon or Mars and keep going. Scientific experimentation in space will benefit massively too. With these habitation modules we can run more and better long-duration tests of human survival in space, which we'll need if we're to establish extraterrestrial colonies. You've been watching 26 Dimensions, the space exploration and astrophysics channel here on YouTube. If you enjoyed this video, maybe you'll like some of my other ones. Subscribe to 26 Dimensions so you never miss out on future uploads. Thank you for watching, and I'll see you next time.